Hi all. Today I am going to discuss about the basic functionalities of Tensor Flow and the functions which are used to build machine learning algorithms using Tensor Flow. Let's start by exploring the basic functions in Tensor Flow. The first function, df.variable, is very common function, which will be used whenever you build any algorithm. It defines a variable that can be used to update parameters, and it is defined by taking a tensor as its initial value, and it can also be a constant or random value. Next function is df.placeholder, which are defined objects, in which you can pass the data through graphs, and when initialized these are just empty tensors. The placeholder requires a data type to be defined, and also the rank and dimension of the tensor. This type of objects are extremely useful for setting up the models, whenever the data values changes. Next one is feed_dict, and this is not a TensorFlow object like other functions, but it is an argument which is used while running the model. It is just a dictionary object that maps the input data to whichever placeholder we want to pass as per our requirements. Next is the computational graph, and these graphs are very powerful as the visualization of this graph helps you understand and debug them. These TensorFlow graphs can have thousands of nodes, and each node represents an operation assigned to the variable. The hierarchy of the nodes can be defined by the visualization, by utilizing all the information. Next is the session variable, which is written as tf.session. It is a class, which represents a connection between the client program, typically a Python program, and the C++ runtime. This object provides access to the devices in the local machine, and remote devices using the distributed TensorFlow runtime. It also caches information of your graph, and you can efficiently run the same computation multiple times. Next is the global variables initializer, where you need to initialize a variable before using it in the operations. If you are using a low-level TensorFlow API, then you need to explicitly initialize all the variables. To initialize all the variables in one go, you need to call tf.global_variables_initializer. Most high-level frameworks, such as tf.contrib.slim, tf.contrib.estimator, and Keras automatically initialize variables for you before training a model. Now, let us start talking about supervised machine learning model, which is linear regression model. The most important function to build linear regression model is the implementation of linear equation, that is, prediction equals wx plus b. To build this equation in TensorFlow, it can be written as prediction equals df.add, df.matmul, x, w, b. Here prediction is the estimated output of the model that is obtained against the actual value. In order to achieve that, we need to build the equation by multiplying the slope w with the feature value x, and the resultant is added with the constant value b. So, tf.matmul is the function used to perform matrix multiplication of two variables, and tf.add is used to add the constant value with the result produced from multiplication. Next is the loss function, which is calculated to find the variation between the predicted value and the actual value. The loss value is always inversely proportional to the performance of the model. So, higher the loss value, lower will be the performance of the model. So our objective is to find an approach to reduce the error in the predicted output, which in return reduces the loss value. So the loss function in TensorFlow is written as loss equals df.reduce_mean, df.square, actual, predicted. This approach of finding the error variation is called as mean square error, through which the loss function is built. Next function is the gradient descent optimizer. Like earlier I have mentioned, to build an effective supervised model, our objectives should be to minimize the loss value between the predicted and actual value of target variable. So this is where the gradient descent function is utilized, and it can be written as optimizer equals df.drain.gradient descent optimizer, learning rate. This function acts upon the linear model we build, by initializing the slope and constant values with the minimum value or maybe 0 and starts adjusting these variables based upon the loss value obtained. The increment rate of the values is decided by the learning rate. This parameter determines how fast or slow we will move towards the optimal weights, and by using this optimal weights we can achieve the target output with an effective rate of accuracy. You can see the figure on screen, how the linear model plots the graph for the features and labels. Here, the blue dots are the data points we provided, and the linear line is achieved from the linear equation we used to build the model. So, the objective is find the best fit linear line in all of these multiple lines, where we could find the optimal weights, to reach the target output as closer as possible to the actual value by using gradient descent optimizer method. Next, is the logistic regression, which is used to predict the binary outcome, either yes or no, 0 or 1, which is mainly observed in the classification algorithm. The logistic regression is an extension of the linear regression, which uses the same linear equation to build the model. In addition, it uses the sigmoid function on the linear function, whenever we are concerned about the probability of target variable as either success or failure. So, the logistic regression model in the TensorFlow is written as prediction equals df.round, df.sigmoid, linear equation. As you can see on the screen, the logarithmic function is applied on the linear model, and this happens when the linear model does not fit well with the data points provided. Then, we use the S-shaped function called sigmoid function. Once you build the logistic model, the loss value can be minimized by using the gradient descent optimizer, since the output achieved will be seen as the probability of outcome, and it ranges between 0 and 1. You can see the two figures shown, where the graphs are plotted based on linear and logistic model, and it is clearly shown that the data points are properly aligned with the logistic model, when the type of data is categorical. The binary outcome of the target variable is transformed into the probability of occurrence between 0 and 1 and built an effective logistic regression model. Next is the clustering concept, which comes under unsupervised learning algorithms where we do not perform any training in order to build the model. The clustering word itself explains that the model we build works on the basis of clusters in the data we have provided, and these clusters are identified by calculating the centroid of the clusters. So, the first function in TensorFlow is shown as centroids equals df.variable of rand_starts. This function is used to first initialize the centroids by randomly selecting n number of points as clusters in the provided group of data points. Here, rand_starts is used to select random data points from the given data points for each group, and this group number can be set manually. Next, the function shown in the TensorFlow is to create the centroid matrix, where we expand the centroids into the matrix, which further is used to calculate distance between each centroid and the data points of the groups. The function can be written as centroid_matrix equals df.reshape of df.tile of centroids length points, so the nearest point to the particular centroid will be taken as one group. Likewise, for all data points, the nearest points to each centroid is calculated and the data is distributed between these three centroids. Next is the distance function, which is used to calculate the distance between the centroid and each data point in the given dataset. The function in TensorFlow is written as distances equals df.reduce_sum of df.square of point_matrix centroid_matrix reduction u_indices equals 2. Next, the function shown is for the centroid assignment, where the closest distance of each data point with respect to the centroid is formed as a group. Here the data is distributed between the number of centroids created. The function in TensorFlow is written as centroid_group equals df.argmin of distances 1. The next function is to build the principal component analysis model, which is mainly used for the dimensionality reduction, where we reduce the dimensions of our groups into 2 dimensions, to facilitate in plotting the graphs, and finding the clusters formed with respect to the data provided. It can be written as PCA_model equals PCA of n_components equals 2. First select the number of components you are using to build a PCA model. Once you set the number of components, the function shown is to build the model on the any given dataset. Reduced_data equals PCA_model.fit_transform of dataset. Now you can see how the clustering graph is plotted, with respect to 2 dimensions of data points, which are classified into 4 clusters, and each cluster is identified by its color and has its own centroid. This is how the prediction can be performed on the basis of clustering model. That's all for this video. For any queries please reach us at vj.reddy@sangam.ai.